Quadratics problems and functions are fairly common on the new digital SAT math section. While some of these problems will require you to have working knowledge of the quadratic formula, many of them can actually be solved very quickly using DESMOS or a few strategies and formulas that can really keep your pacing excellent and save time for some of the more challenging and difficult questions later as you progress through the math section. Today we're going to go over some of those strategies. My name is Will. I'm with Principia Tutors and Consultants, and let's get started. So here are some of the strategies we'll be covering. And so finding the sum of all solutions to a quadratic function using DESMOS, finding the products using DESMOS, and finding the sum and product of all solutions when DESMOS is not a viable option. So make note of the following before we jump too deeply into this. To find the sum and product of all solutions, the quadratic function must have solutions in the real plane. We can confirm this by using the quadratic discriminant, so the formula b squared minus 4ac, so it needs to be greater than or equal to 0. So if it yields a value greater than or equal to 0, we're cooking with gas. We can then apply these formulas. If it has real solutions as written in standard or vertex form with clearly defined coefficients, go ahead and use DESMOS. It will be much faster, and you want to save as much time as you can whenever possible. When DESMOS is the slower or less viable option, we're going to cover some formulas later in this video that you should apply. For these formulas to work, please remember the quadratic function must be written in the standard form, so ax squared plus or minus bx plus or minus c, with a, b, and c being the coefficients in front of the variables. All right, so when we want to avoid the quadratic formula when DESMOS is our fastest method. Here's our function, 5x squared minus 45x plus 10. So we want to find the sum and product of all solutions to this function. First off, let's make sure our quadratic function has real solutions using that quadratic discriminant. Now, you can go ahead with that, but to save time, just plug it into DESMOS. Make sure that you've typed everything correctly, and if you're seeing the function intercepting the x-axis, then we know we have real solutions. So this is the output you should get if you type the function incorrectly. The x-intercepts are highlighted because if we want to find the sum of all solutions, we just add our x-intercepts. If we want to find the product of all solutions, we would multiply the x-intercepts. Here, adding the x-intercepts will give us a sum of 9. Multiplying the x-intercepts will give us a product of 2. All right, moving on. How about when we're dealing with a vertex form function? So here, finding the sum and product of all solutions to the function, very similar to the last example. If it's in vertex form, you can just plug it into DESMOS. Make sure your typing avoids any sort of error so you can double check. Confirm the function has real solutions by confirming it does intersect the x-axis. Then again, the sum of all solutions, you're just adding the x-intercepts, and the product of all solutions involves multiplying the x-intercepts. Here's the output. And so the sum of all solutions is going to be 16, and the product is going to be around 61.80. So just a fun reminder, if you are asked to input it for a grid-in question, remembering that if it's a positive answer, you're going to have just 5 character spaces, so that would just be 61.80. All right, what about when DESMOS is not the best option? And so first, if the function is already written in standard form, again, that's ax squared plus or minus bx plus or minus c, use the quadratic discriminant, which is b squared minus 4ac, to find the values of b or c when they are undefined. If b is undefined, remember b squared minus 4ac has to be greater than or equal to 0, or when you want to isolate the b value, b squared needs to be greater than or equal to 4ac, and then you can resolve from there. If c is undefined, take b squared over 4a, set it greater than or equal to c. That would isolate c, which is what we'd want to find in this instance. To find the sum of all solutions, you take negative b divided by a. To find the product of all solutions, you take c divided by a. Again, for the formulas to work, the quadratic function must be in standard form. If it's written in vertex form, remember to convert it to standard form first, then apply these formulas. Just to really reiterate and reinforce this, memorize these formulas and make sure it's in standard form when you apply them. All right, let's give it a try when Desmos is not as viable. As we can see, C is not clearly defined in this quadratic function. However, it is written in standard form, so we don't have to go through as many steps. So find the C values that give the function two real solutions, and then find the sum of all the solutions to this function. So first, we'll start by finding C using the quadratic discriminant. Using b squared minus 4ac, again, since we want c, that would be the b squared divided by 4a must be greater than or equal to c. Plugging in everything and doing the math will work it out to c should be less than or equal to 168.75. Since the function's in standard form, we can find the sum of all solutions very easily. So again, reminding you of the formula, it's negative b over a. In this particular instance, that would be the negative of negative 45 divided by 3, or 45 divided by 3, which gives us 15. This sum of all solutions will be true for the real plane as long as c is less than or equal to 168.75. All right, let's try it with another example. This time we're going to look to see if we can find the product of all solutions to the function. All right, so start by finding b, because that's what we're being asked for, and b is undefined currently. So you take b squared minus 4ac, or from the previous slide, we'd have b squared needing to be greater than or equal to 4ac. Plugging in the numbers, working the math out, would come out to b should be greater than or equal to 8 or less than or equal to negative 8. Since our function's in standard form, we can find the product of all solutions using the formula c divided by a. In this instance, with c and a being clearly defined, we would just take 8 divided by 2 and it would leave us with 4. This product of all solutions will be true for the real plane as long as b is either greater than or equal to 8 or less than or equal to negative 8. All right, now what if we have a vertex form quadratic function? This is more challenging, but still manageable. So if we want to find the sum of all solutions, find the product of all solutions, first thing we need to do is we need to try to convert it to standard form. So converting from vertex to standard form is our first step. Writing it out, after foiling and distributing, we should have a negative 3x squared minus 6xh minus 3h squared plus 24. It's important to note that that negative 3h squared plus 24 is the c value, while the negative 6xh, that's going to tie into b, where negative 6h is b, and negative 3 on the x squared is our a value. All right, using the quadratic discriminant, which is the b squared minus 4ac, setting it greater than or equal to 0, working out our math, we should end up with an h value that is greater than or equal to 2 or less than or equal to negative 2. So this gives us a huge range of potential answers. So using this possible set of solutions where h equals 3 because it satisfies the condition of h being greater than or equal to 2, let's plug in a 3 everywhere we see an h in the original function. What we'll end up with, working out everything, is a negative 3x squared minus 18x minus 3. The sum of solutions, again, take negative b divided by a. So that would be the negative of negative 18 divided by negative 3, or negative 18 divided by 3, which is negative 6. The product of our solutions, which is c over a, is going to give us negative 3 divided by negative 3, which is 1. All right, quick recap of the quadratic strategies, and you're free to go tackle some of these on your own. So first thing to remember, when it's written in standard form, try Desmos first. If Desmos isn't working well or quickly, use the quadratic discriminant to confirm the function has real solutions. If it does, the sum of all solutions is negative b over a. The product of all solutions is c over a. If it's written in vertex form, again, try Desmos first. If it works quickly and it works well, move on. If it's not working well or quickly, that's where we need to convert the vertex form to standard form, use the quadratic discriminant to confirm the function has real solutions, and then we'd apply the correct formula to solve for the sum or product of all solutions as directed by the question. That's it. Thank you so much for watching. If you found any of this information helpful, useful, interesting, thought-provoking, please like, comment, subscribe to the channel, share the video with a friend, and please check out our other DSAT videos in this playlist. All right, thanks again. This is Will with Principia Tutors, and I'm signing out.